Well, welcome everybody back to the Integrity Podcast. We're doing something a little bit different. We're actually live here at TSDOS 2022. I have a great guest today, Blake Tucker with AEP. It's going to be a fantastic conversation and really look forward to it.
Integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast. Powered by EXO, hosted by Zachary Oliphant.
Well, guys, welcome. What a fantastic day. Get a chance to interview Blake Tucker. And let me just introduce Blake first and foremost. Blake's a staff engineer with American Electric Power. He graduated with a B.S.E.E. from Oklahoma State University. Blake is a registered PE in the states of Texas, Oklahoma, and New Mexico. He has 36 years in the electric utility industry in various roles. He's been a staff engineer in the Transmission Line Standards Department for the last 8 years. He's also a member of NESC and has participated in the NESC 2012, 2017, and 2022 code cycles on Subcommittee 4. And he's also a member of the NESC Interpretation Subcommittee. Blake is also a member of NATF Lines Core Team and IEEE. Mm-hmm. That's a lot, Blake. Obviously, that comes with all of your experience. And welcome to our podcast. Should be a great conversation to get to know you a little bit more, get to hear your story. And most of the folks that we bring on, we really like to just start with an origin story. You know, what really got you into engineering? What was your path to where you are today? And so maybe we can start with that.
Sure. So it was grew up in a rural town in Oklahoma, a pretty small school. We didn't have guidance counselors, and nobody really even thought about that. And was just in a science class one day and talking to somebody, and he asked me what I was going to do, and I thought, I don't know. He said we should try engineering. I said, well, okay, I like science and math, so I got into engineering, and then in the summers I was working at a power plant. Really taught me that I liked the utility business as a whole, but I didn't like power generation. In the summer on a coal plant, everything's hot, dirty, dangerous. So that wasn't the environment I wanted, but I did like the utility business. And so kind of through that and through engineering, started taking power classes, and just that's the way it worked out.
Oh, awesome. Well, tell me a story about you working in a power plant at a young age. That's got to be an interesting experience being a young college guy and working with some of those guys. Probably been doing that for a long time.
So the first 2 years I was on the yard crew. We did a lot of mowing, a lot of weeding, and then the second 2 years I was in the electrician shop, and that was pretty interesting. Of course, you know, in the summer it's a base load plant, right? So you tiptoe around those generators because you don't want to do anything to shut them off. We just happened to be in the control room one day, and somebody was out in one of the substations putting a relay in or something, and jiggled one of the relays, tripped the breaker, so tripped all the load off of one of the turbines.
Oh, wow.
And if you've never been in a control room and that kind of thing happened, every annunciator, every alarm, everything was going off. People were running around, and we were just trying to stand there in the corner and be quiet.
Big fly on the wall.
Yeah, it was really interesting though.
So they have this alarm go off. Obviously, it's an issue for them. Kind of walk me through that experience as you're sitting there watching everybody, you know, try to attack and solve that problem.
Part of it was, you know, that the generator's spinning and you've got all the energy going to it. Now all of a sudden the load's gone, so the generator overspins. So those alarms go. There's the alarms from losing load, and then there's like a steam pop-off valve really for that whole turbine system. The turbine deck was right outside the control room, and just watching them do that whole scramble around and get it under control, and then to get it back, we stayed there the whole time to watch them get it back online, and how they had to match the speed and get it close to being synchronous before they close the breaker. And you know, I'd always thought, well, surely they've got something more technologically advanced but it was a light bulb and a light bulb and a synchronoscope on the wall, and we'd done that in lab and kind of knew the theory behind it, but to see them actually do that in real production was really surprising.
Oh, that's really cool. Yeah. So they get it all balanced and get everything back online. And that's a lot of what people don't understand, just how complicated the grid is when it comes to the generation, balancing with the transmission and the consumption of power. So walk me through, Blake. You've worked in a power plant. You're introduced to the utility business. Kind of what is the next step for you?
So as you said, I graduated in 1986. Went to work for a small company called Texas New Mexico Power, and in Central Texas. They're a small enough company that they didn't have transmission engineers and substation engineers. You were the engineer, and so you got to do all kinds of things. My first exposure really to transmission was, I think, within the first year of being out of school. My boss says, we're building 30 miles of 138 wood H-frame. Go be the inspector on it. I said, huh? I got an electrical degree and I didn't know anything. But it was a great learning experience to be out there. Just to see the whole process and how that happened. It really gave me the bug that drove me later on to get to engineering. I spent 10 years at TNP, and like I said, they don't have transmission engineers, so I was really exposed to a lot of different areas, which is really good. But always there was that transmission bug that kind of kept drawing me back. And in fact, after that was done, the following year we designed our own. My boss says, well, you can do it. Well, no computers in, no PLS CAD. So we got the hand-drawn P&P sheets, and I cut my own SAG template out and started drawing it with pencil, and that's how that thing was designed. So that whole process, again, was just a great learning experience because you had to figure that out.
Yeah, I was going to say, awesome experience to work at a smaller utility like that where you got exposure to a little bit of everything.
Yeah.
And that's how we learn, right, is
Sure.
by doing. And for folks that don't know, P&P, plane and profile, so that's looking at sags and tensions on structures. And it's interesting to talk to folks that have been around a while where you guys were doing everything, hand-drawn. It's really amazing to go back and see some of the things, probably lines that are still up and operating today that you would design.
Yep, absolutely.
Well, good deal. So you're at Texas New Mexico Power for about a decade, and then what drove the shift in your career? You had this transmission bug. So walk me through that.
There was that. We wound up out in New Mexico, Silver City, New Mexico, which was a nice place, but it was way far from family. We had two small girls, and our family was back in Oklahoma. My wife's family was back in Oklahoma. It became time to move home. If we were ever going to go home, once you stay at some place, it's harder to leave the longer you stay. We were at the point where if we don't do it now, we're never going to do it. And so we made the decision then to move back to Oklahoma. I got a job with CSW then in their distribution design department. Then AEP bought us out, and I took the advantage to jump into transmission and have been there ever since.
Okay, awesome. So now you're at AEP, and you've been at AEP for going on, 25 years, something like that, so a long time. So kind of walk me through that experience, your kind of history with AEP. Obviously, AEP has grown a tremendous amount. They're one of the largest utilities in the country, if not the largest. Certainly up there. So kind of walk me through kind of your history there at AEP and the various roles that you were in.
So started out in the transmission department, just a design engineer, and still really learning the craft, right? Because I'd come from that and done one line, and I talked them into let me try it again. So they said okay, and by this time we had PLS CAD and early versions of PLS CAD. So it was really a big learning experience. But there were people that were way experienced around me, so it was a good learning opportunity. Eventually, the way we were growing, the budget kept getting bigger and bigger. They decided to make supervisors in the line engineering department, and so I got to be a supervisor there. Didn't do so much design work as supervising, and that went along for a while. And then along came CREZ, and we'll probably talk about that later on. But it was a pretty big project.
Yeah, I'd say so.
Our part of it was, and through several issues that we had on there, I got exposed to another side of the business rather than design. It was more the inspection, lab reports, failure analysis, things like that I really found I enjoyed. And so the opportunity came up. Our transmission line standards group created a spot in Tulsa, and I heard that was happening, and I said, I want it. I'll take it. And it surprised everybody because I'm jumping out of supervision into just being an engineer, but really it got me into doing what I'm doing now, which I love. And so I talked to my boss and told him the other day, I'd never even thought about retiring. Why would I retire? I'd get paid good money to do something I like to do and work with people I like.
And it almost harkens back a little bit, Blake, to this because I've been with you in the field, and our team spent time with you in the field where there's big issues. You spend a lot of time going out in the field, And it almost is this corollary to your early days where you're out in the field and seeing how lines are being constructed or maintained, or a line gets hit by a tornado and you're out there trying to assess, what do we do, and what is the right amount of inspection or remediation, and what are our issues, or what are the issues that AEP is contending with. So kind of walk me through your CREZ experience, and for folks that don't know, here in the state of Texas, ERCOT did something that was pretty kind of revolutionary at the time, which was to figure out how to get all of this really good wind area in West Texas, where, no offense to the folks from Odessa or Midland, but not a lot of people live there. And you're trying to get all of that potential renewable energy power back to population centers. And so the state set up these competitive renewable energy zones that both incumbent utilities like AEP and others got an opportunity to basically bid and talk about building transmission lines. Kind of walk me through that experience and your involvement there.
It was really probably one of the most challenging projects I've ever been a part of. Right, originally we were talking about maybe even contracting it out, and I said, Stan, we don't want to do that. I mean, never are we going to have an opportunity to do this again. Let's get a bunch of people involved and we'll get it done. And so I got to be lead engineer on that. As I said, there were lots of problems. We had to make lots of early decisions because of the pressure, political pressure to be done on time and on budget and all those kind of things. And so it was a pretty high profile project, but it really taught me a lot about just the process and getting things done and how important it was to get out ahead of things. Plus, as I said, it exposed me to a different side of the business that I've really enjoyed and kind of moved over into standards now.
Yeah, so maybe we'll talk a little bit about that, Blake. I mean, the interesting thing from my background on the manufacturing side at that time period, so this is, late 2008, 2009, 2010, when all this was going on, you basically had this huge demand of utility structures on top of just the regular demand that's going on. And you had manufacturers really from all over the world trying to compete over building material for these lines, and it stressed the system like it's probably never done before.
Absolutely.
And as a result of that, as you can imagine, when you take manufacturing capacity and you try to double it or triple it, you can run into some real challenges from a manufacturing perspective, a quality perspective, a trades and crafts perspective. So maybe walk me through some of the challenges that you're willing to share related to that, and kind of what maybe drove you into standards and the importance of standards.
Sure. So we started seeing problems, and I can't really get too specific about who and what, but there were quality issues that popped up. There were some issues that popped up that were based on the size of what we were doing. Right, the structures we were using were 150 to 200 foot tall and pretty long spans, and so I personally never put up a pole that big. When you start welding and trying to put that thing together, there are issues that don't show up on the smaller poles.
Yep.
There's the issue, the QA/QC, like you talked about. We didn't reduce our normal budget or anybody else when CREZ came along. We just dumped CREZ on top of it. And so it really pushed and stressed those vendors as well as the labor contract providers, right? So it was a pretty stressful time for them as well. And I think it exposed some weak spots in some of their processes that we have worked with them to address. But it was the investigation part of it really that got me into where I am now. Absolutely.
And like in any industry, you stress the system like that, you're going to have challenges, and you're working. I mean, most of those plants at the time were working round the clock to produce material 7 days a week. And when you're doing that, it's opportunity for human error to be introduced to what's going on. And the challenge on some of these CREZ lines, it's not a 20-mile line, right? It's hundreds of miles. And so if you have a problem, it's a much bigger problem, right?
There's a lot of it.
There's a lot of it, and it becomes a big challenge. And maybe walk through, Blake, a little bit. I mean, you guys were fortunate. You found these issues, and a lot of that from your leadership and your team being out in the field. Found it early enough where it was really kind of under a warranty, covered under warranty. Maybe the importance of that. I mean, you guys are, you're buying structures that have a 40, 50, 60-year service life. But to this day, I think the standard warranty is still a couple years, 1, 2, 3 years. And so it's a relatively short warranty that the manufacturers give. And you guys now have to maintain these lines for a long period of time. Maybe walk me through the importance of what you guys did then and maybe what you do today when it comes to trying to understand and how to enforce a warranty. And
so we always had inspectors out there, but weren't really focused too much on material quality. We had vendors that we were pretty comfortable with and had been using for a long time for the most part, and so we were pretty comfortable with them, and these things started popping up, and as you said, it was pre-warranted. And I think that we really pushed ourselves and pushed the inspectors to know that you need to take a little better look maybe at that. We've started some in-plant inspections on steel poles, which we had never done before. And so we've kind of reacted to it that way. And it seems to have been pretty successful so far. But I think there's probably more to come with that.
And I think you're right, Blake. I mean, it's this kind of trust but verify, right?
Sure.
I mean, you want to have good vendors, good relationship with your vendors, but they're human too. And the craftsmen and women that build all these structures, I mean, it's almost all done by hand fitting, hand welding. And when you stress the system, it's just natural that things can fall through the cracks. So walk me through. So now you're in standards, right? And you're helping with that. I mean, walk me through kind of the importance of that for AEP and really for the industry as a whole.
So it's kind of funny. I was in transmission before AEP or right at the beginning of the AEP buyout. CSW was the company that they bought out that I worked for. Didn't have a standards group, and so the design people really kind of did their own. And obviously, our first thought is, well, standards group. What do we need them for? I don't need somebody telling me how to do this. Since though I've got to know standards and what they do, and the testing and the material verification, everything, all the research they do, it's so important. Like right now, I'm doing one of my big projects is we're working on improving lighting performance of our transmission system. And so how are we going to get that? Well, it starts at standards. I've got to do the right standard. I've got to do standard measurements. I've got to use the right structures at the right place. I've got to look at the right things. And so we're kind of writing that process up just to try to improve that lighting performance. We get involved in all kinds of things like that are very important.
Absolutely. And we spoke here at our pre-conference workshop about just having those conversations up front with whatever supplier it is, whether it's on poles or transformers or any other materials, is you all being able to lay out what is important and what standard everyone's being held to, and how critically important that is to be done up front, and make sure the vendor and the end user, like an AEP, everyone understands what the expectation is. Usually when that's all done up front, things go smooth.
Absolutely.
It's when things change in the middle that people start having real challenges.
I believe we have that kind of relationship with our vendors. At this very conference, there's several of them here, and I get to see them again, and it's kind of like seeing old friends because we know them, we work with them, and usually it's on the phone, but to meet them in person, it's always good. And so I agree that relationship is so important to get quality products and the quality products that you need and that you want, all that.
Absolutely. So walk me through, you guys did an awesome presentation this morning here at TS-DOS related to a failure you guys had, and maybe give me some details on that. I mean, that's kind of right in your sweet spot, right? It's the kind of trouble man, something happens, something falls down, and all this kind of forensic work you've been doing over the years.
It's been great. I got to work with Ken and Mike on that, and so, we had a fairly new line. It had been in service for about 13 months. High winds blew through, but not a tornado. So we had winds that we recorded up in the 70-mile-an-hour range, and actually lost about 1.5 miles of line because of that. And so, the analysis showed that at 70 miles an hour, those poles shouldn't have been more than 50% loaded. So obviously, something happened that affected that. As we dug deeper and deeper into what went on and what was out there, it became more and more apparent that the structure that started the cascade had some problems at a slip joint, and so we got into that and looked at what all needs to happen to make a good slip joint, and we've got millions of those out there, right? And slip joints aren't just failing right and left, so it's a pretty foolproof way, and if you do it right, it's even better. That very first line that I was the inspector on, we had slip joints. They had a dozer on one side and a big truck on the other, and they're just driving and slipping. There was no jacks.
That's how you jack
no
them
jacking,
together.
no nothing like that. I just got two big trucks and I'm mashing them together. And we're hopefully a little bit more thorough about that then. But that slip joint, in that case, something happened. It wasn't quite installed right, and so it didn't act like a good slip joint, and it caved at the 70-mile-an-hour wind.
Yeah, and that's kind of the interesting piece. I mean, some of these, because we investigate a lot of failures. And sometimes it's a manufacturing related issue. Sometimes it's a weather, a capacity of the particular member or structure issue. And sometimes it's an installation issue or some combination of all of those.
Yeah.
And it makes it really difficult for someone like you and for folks like us. You're trying to evaluate all of that and just understand root cause.
Sure.
So we can all learn from it and make sure that the next time you're building a line, those things are looked for and you're trying to catch them. I think it is kind of interesting, Blake. I mean, we're seeing of most of the catastrophic failures we see are relatively new poles. I know Wes Oliphant with us, and we chat a lot about this. Like, why is that? And we like to think part of it is just because the technology and the design analysis have gotten so tight that you can optimize a pole to as optimal as you can get it, which is great. I mean, it's fantastic. It saves the folks like AEP money. But the challenge, you got to build it perfect and you got to construct it perfect, right? And those are some of the things that I think, like you said, we're seeing kind of come out of this optimization of design. The manufacturing's trying to catch up to being perfect or as close as they can get. And then certainly on the construction side, you guys have good standards in place, trying to have everyone doing everything the same way, but it doesn't mean that everything is perfect every day.
That line we were just talking about, I went back into PLSCAD and did that structure utilization check. We had poles that were designed to 97, 96%. And today we look at that and say, well, that's a good, efficient line.
Yeah.
20 years ago when I started transmission, I would shoot for 80 to 85.
Yeah.
Just because you don't know that and you don't know what's going to happen during construction and you don't – there's so many things out there that could happen. To have something at 95% would have scared me to death. But now, like you said, we've got better tools. We've got better control over how they're installed. We feel much more comfortable cutting it that close, and I think you're absolutely right. I think that's given us some problems. Yeah,
absolutely. And I think we're all learning from that, right? Sure. Is where's the push and pull and how close to that edge do we get? One of the other things I want to chat with you about, Blake, so we talk a lot about renewables and CREZ. Is maybe your perspective on this huge shift that we've seen over the last 15 or 20 years to renewables here in the U.S. I mean, you started your conversation with talking about a coal power plant. AEP has shuttered a lot of them, and most utilities in the country, because of political pressure and other reasons, and because of new technologies, are shuttering a lot of their coal power plants and coming on with combined cycle and renewables to backfill that. But it creates some interesting challenges on the grid. Maybe speak to that a little bit.
Sure. I think we as an industry are really in a kind of a precarious spot right now. Tremendous pressure to go green, right? Yep. More and more renewables, more EVs, electric vehicles, more everything greener, better, which is great. I mean, we should be pushing there. The problem is we don't have the technology on the other side of that to make that happen. Like I think we've seen some signs of that now. That the grid is almost pretty saturated with renewables as far as what we can do with them. At some point you have to have a generator that runs at night when the wind's not blowing.
Yep.
And so how do we get that, and how do we control the grid with that level? Start to generation that goes into operations and transmission. We've got to whatever that solution winds up being, we've got to be able to get that from where the generator spot to the load, and we've got to do it fast. It can't take 5 years or 10 years to get a line built. We have to be able to do that faster. You can look at distribution and distributed generation. That's going to have to be part of the key too. Mm-hmm. And so our industry, from top to bottom, generation to distribution, is really being pushed. And there's got to be some technology that's got to happen pretty fast for us to do that. Fortunately, the industry as a whole has a lot of really smart people in it. Yep. And so it's going to happen. It's just going to be a little painful maybe sometimes.
Absolutely, and it's interesting to see an industry kind of as old as the utility industry is in the U.S. seeing such huge change so fast. And like you said, it puts a lot of pressure on the whole system and everybody. And for most folks that aren't in our industry, they just think you flip the light switch and the lights always come on and it's just easy. It's obviously a lot more complicated than that. And like you said, if the wind's not blowing and you've got demand, you've got a problem. If the sun's not shining and you've got a lot of solar capacity generation, and you have demand, you have a problem. And it's trying to balance those two, and whether that's done with utility grade storage, which a lot of folks are working on, or it's other types of generation to help deal with peak demand. But it's a tough and complicated and expensive proposition to try to get right.
It is. It's going to take a lot of work and a lot of understanding and communication because a lot of times the decision makers in politics aren't really aware of what the difficulties that what goes on, and so it's going to take a lot of education, I think, on our part to the decision makers as far as how we're going to make that work.
Yeah, it sounds great to just do it overnight,
Yeah.
but like you said, I think we're on this kind of precipice of, and like you said, there's brilliant people working on this. I think we'll get there, but it's going to be a challenge to get there and get there very, very quickly.
I think so, and it's really pretty exciting because, like you said, our industry is pretty slow moving. I wouldn't call it stagnant, but slow and steady is a good word for it. And now all of a sudden we're being pushed to do things pretty fast, and so it's kind of exciting.
Well, and you guys, traditionally being slow and steady is important because what you deal with is dangerous. I mean, it's
True.
you deal with high voltage work, and so people want to be careful and very deliberate about everything that's going on to make sure it's being done safely. And so some of that kind of regulation, you talk about standards, some of that regulation and some of those standards and all those things you're trying to do, it's to keep people safe and it's to keep power on all the time and be reliable and resilient.
Absolutely. I'm thinking of our workforce, like the engineering workforce too. As far as standards being important, we have lots of really young engineers, and they're super bright.
Yep.
They're coming out of school miles ahead of where I was when I graduated, but they don't know things. They pick up a tool like PLS CAD, and they're so fast at learning that program. It's easy to forget the depth of knowledge that they don't have. And so standards, I think, really are important as far as just giving them a path. This is a path. You stay in this path, and you should be okay. We're going to try to teach you all that other stuff as we go along and hopefully mentor you and bring you along. But in the meantime, these are the standards. If you stay within this path, you're going to be good for 99% of the time.
Absolutely. Well, maybe walk me through that. You mentioned kind of young engineers joining AEP. I know AEP's added a lot of engineers over the last couple of years, really gone kind of on a hiring binge because of all this work that you guys and other utilities have. What's some advice you'd give to a young engineer, someone coming straight out of school, coming with a very different skill set, raised with technology from basically being little kids, and applying that. But again, you're applying software and understanding the theory and methods of what's going on. A little different than you drawing your plan and profile by hand, right?
So it's so important not to get caught up and let the program do it for you. And so you have to really push yourself to get deep into why is it doing this. If it tells me something's overloaded, I go, well, it's a 10% overload. Well, what does that really mean? Is that some thing that you didn't even model right, or what's causing that and why? And digging deeper. And that would be, I think, my advice to somebody. Don't be too anxious to throw away just a calculator and a pencil. If you can do it with a pencil on a piece of paper, then you understand the process, and it's much easier, much better to understand what the computer's doing if you do that. And I've always liked that. A lot of people don't, design a structure by hand. Nobody wants to do that anymore, but that's invaluable. If you know enough to do that, then it's invaluable.
Absolutely, yeah. If you understand the theory behind it all, I know Wes talks about that a lot, and we spoke about that a lot on our podcast here on slide rule and Big Chief tablet, and you're sketching it out, but knowing what's driving the software is critically important to be able to question, are the results right?
Absolutely.
And be able to challenge the results that you're getting and make them make sense instead of it just being an output and then you just check a box and sign off and move on.
Yep, exactly. It's so important to know what's going on.
Absolutely. Well, one of the things we like to ask everybody on our podcast, Blake, is, it is the Integrity Podcast. And so maybe you have a story about either a personal story or a work-related story around where either integrity had some great outcome or where you maybe saw someone cut a corner on integrity and created a big problem that you were involved in.
I think it would go back to that first transmission line we talked about. The guy who was the general foreman of that line was Calvin Hargrave. He eventually became president of that company. At that time, I didn't know enough to know what he was doing. I trusted what he said. Well, if he said this is what we always do at ACE, and
yeah.
Okay, and trusted him. As I've grown into the transmission business and knowledge, I can look back at that and say, everything he taught me was true. He had the integrity to do things right the whole time, every time, and that's so important. AEP has that. We kind of talk about that, doing the right thing every time.
Yep.
And it's important to reinforce that, and to get that kind of trust. I mean, people, even as a supervisor, to know that you look up to your manager and you know that he's always going to do the right thing by you every time, and and it is always going to be truth, and those kind of things. That integrity is important.
Absolutely. And it's built, like you said, it's building that culture where people are doing the right things all the time, even when nobody's looking, right?
Absolutely.
And you guys as engineers just naturally have to be doing that. I mean, you're kind of the final say on, what are we building and what are we putting up that should be there for the next, 40, 50, 60 years that's going to be delivering power to, a lot of people, a lot of homes, and certainly the integrity around all of those little decisions that have to get made have to be done right.
It's important, absolutely. I mean, and it's important to even down in the little bitty details. It's to be in to have integrity. I'm not going to rob a bank, or somebody loses $1,000, I'm going to pick it up. But somebody loses that penny or something, so those little quarters, those things like that, when you can show integrity at that small level too, I think that's also important.
Absolutely. No, I agree with you. Well, Blake, awesome conversation. Appreciate you being with us today. It's been great to hear about your experience and all the great work you guys and AEP are doing. And you're welcome back anytime. Happy to have you, and good luck to you moving forward.
I appreciate it. It's been great. I've had a good relationship with XO for a long time, and look forward to a lot longer.
Sounds good.
Appreciate
Thank you,
it.
Blake.